Hey, fourth graders, Mr. Strongslin here. I wanted to make a video to kind of review some of these math concepts that we're doing in IXL this week. I also attached a bunch of links with this to people other than me explaining it if you wanted to try it from somebody else. If this doesn't work and you want to try a different explanation, or if you still have questions, please send me a message. I'd be happy to help anybody that's still confused. So I'm going to go over all of these for this week. We got number sense that we're working on for two of them. Uh, and these should be or some of these might be highlighted depending on which class you're in. But take a look at these two for number sense, whether it's identifying place value or the prime and composites part. Letter T, if you go to section T, it's the first one, decimals. And we'll talk about that in the next part here. Letter W, we got two-dimensional figures. We're talking about line segments, and rays. That's a tricky one that some kids get mixed up, but if you go ahead, you can find that part. I'll explain it. And then letter Z, we're talking about angles of 90, 180, 270, and 360. So take a look at that. In the top of this video, I'll have the different part that I'm working on. So if you just need to skip ahead, you could. I'll do them in order. And if you skip ahead in the video, you can see at the top of the video which one I'm talking about. And I'll try to give you guys a review of how I taught that in class and hopefully help you guys remember how to do that for yourselves. So again, if you need to skip ahead, do that, but I'll try to go through all five of these and give you a really quick review to help you guys remember what we did when we talked about those. Let's get started. The first one was talking about number sense. So when we're identifying place value names. So when we do a place value, keep in mind we always start with a decimal. That's going to be the biggest thing. If there isn't one, you assume it's at the end of the number, but we always start with a decimal whenever we're dealing with number. It's that little tiny dot. We always use that when we read a number. We call it the and. But we're going to start with the decimal, and that's going to be there. So everything else, if we go to the left of this, we're going to have the ones, the tens, and the hundreds places. Okay, so that's really important. Ones, tens, hundreds, it's always in that order. So for very simple sake, if I had a 1, 2, and a 3 here, we would read this as 123. Very straightforward. The other thing to keep in mind is if you were to build this number using base 10 blocks, those are those things you guys started with in kindergarten. Those little cubes, and then those rods, and then the flats. So here we're going to have 3, they're usually blue. So we would have 3 little cubes here. That's how you'd represent 3. If you put 10 of these together, you would then have what we usually call a long, or sometimes I call them rods. And those would be those long ones that look like this, right? But here I've got a 2, so I'd actually have 2 of those, right? And there would be 10 of them there. It looks something like that. I don't know if I actually drew 10, but you have the idea. So that'd be that. The hundreds would be if I get 10 of these together, right? So the rods are 10 of the smalls, and then if you put 10 rods together, you have a flat. That's that one that looks like this, right? You'd have, looks like 10 different rods. So that's how you'd build that number using base 10, and that's the hundreds, tens, and ones. So kind of keep that in mind as we're doing this and going ahead. Let me just get that out of the way for now. But it doesn't just end there. After we get 3, we end up with a comma, and we can keep going a little bit further. All right, so this one is going to be the thousands, the 10,000s. Oh, almost remembered. Remember, it's the 10,000s, and this would be the 100,000s. Place. So thousands, 10,000s, 100,000s, right? And these would be the next numbers. In fourth grade, we don't go any further than millions. That would be the next spot, but after that, it would be 10 millions, 100 millions, and so on and so on. You really only have to worry about these spots right here. This would be our million spot right here. And that's what we do in 4th grade. Now it's really important to note the commas that are in here. We name this one, this is our millions, and this one over here is the thousands. And that is important. If you notice, I kind of colored them that way. So I've got a red, yellow, and blue section. These are important as we read a number, because if I were to put a number in here, and I'll just kind of put some digits in here, I would read this as 4,376,000, comma, 123. So those commas tell us when to say a word that's not a number. So we read this as just 4,376,123. Of course, sometimes we do have numbers over here as well. It doesn't just end at a decimal. And in 4th grade, you only have to worry about going 2 spots to the right of a decimal. So we could go here and here, and these are really all you have to worry about. This one is there is no 1ths place, but we are going to add a th here. This is going to be our 10ths, and this one is our 100ths. We had that th. So here, if we had that cube like we had before, our one little cube, if I took a little X-Acto knife and did the best I could, and I cut this little piece here into 10 different sections, I sliced it really thin, had 10 different sections, that would be what this is. And if I did that again and cut each of those little 10 pieces into 10 more, I'd end up with 100ths. So we're dealing with tiny, tiny pieces here. A lot of times when we think about these, we talk about money, right? This would be money. Here we're talking about $3. You could take a dollar, turn it into dimes, and turn it into pennies. And we'll talk more about that actually in the next one. So remember, whenever we get to here, we would say and. But I just wanted to go over, as long as you remember ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, it should make it a little bit easier, especially as you're doing this in IXL. Taking a look at prime and composite. Sometimes these are really tricky. I try to make this fairly simple. And a lot of you guys remember doing arrays. Arrays are those funny little things. It's basically just making a box out of numbers. And so if I gave you a number like 12, we can make arrays in several different ways. We could make an array. We could make it go, let me give you a couple different colors here. We could do a box that's 1 by 12. We could do a box that is 2 by 6, or we could do one that is 3 by 4. And what I mean by that, when I'm talking about arrays, let's build them. So let's do this one in blue here, 1 by 12. That would be simply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I've got 12 different dots in a row of 1. I could also take this and do it the same way and put it the long way and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's the same thing. These are both going to be 12 by 1s, and regardless of how we did it, whether it's 12 by 1 that way or 1 by 12 this way, it's 12 different dots in a rectangular shape. So let's try it and do this in a little bit different. Let's do a 2 by 6, and let's do it in green. So my 2 by 6, I've still got my 6 dots. Or sorry, I'm going to make 12 dots, but I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now I've got a 2 by 12. So it is 2 high by 12. Or sorry, 2 by 6, which makes 12 dots. It's 2 high, 6 wide. It's 12 dots. I could also make it go in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Either way, these are both going to be a 2 by 6 pattern, right? Either way, I'm making a rectangular shape, right, with 2 rows of 6 or 6 rows of 2. It's the same thing. Either way, when I multiply those together, it's 12 dots, right? Whether I've got 12 dots here and a 1 by 12, 12 dots and a 2 by 6, or you can do a 3 by 4. Let's make that one yellow. And if I do these, I can go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And again, I've got 12 different dots in a rectangular position. I could also do the same thing in another direction. 1, 2, 3. And I've got 12 dots. And that's what the idea here. It's still a rectangle. I've got just as many in each row, just as many in each column. 3 by 4, 3 by 4. They all equal 12. So I've got 12 here. I've got 12 here. And of course in blue, they're both 12. And so I've made different arrays, right? And that's just an array. That comes back to how we can make a prime and composite, because it depends on how many arrays we can make. These are all essentially factors. When we talk about factors, right, we've got a factor times a factor equals a product. Okay, it's essentially the number that we multiply by. Those are just the fancy terms. So whenever we multiply two numbers together, we get a product, and the two numbers that we multiplied are a factor. So factor times a factor equals a product. So we've got these. These are all factors, okay, and the products are all 12, because they all multiply that. All of my boxes have 12 dots. Even though these long, narrow ones have 12 dots. Okay, so let's take that a step further. So let's continue that idea of arrays and deal with prime and composite. A prime number is any number that has two factors and only two factors. It has exactly two factors. That's what a prime number is. So for example, if I gave you 3, if I wanted to do 3, and if I wanted to make an array of 3, there is only one way to make an array of 3. I could go 3 by 1, or I could go 1 by 3. Those are the only two ways I can make an array. I cannot do it another way. If I try to go 2 and then 1, this is no longer a rectangular shape. This is a rectangle. This is a rectangle. These are great. That's a rectangle. That's a rectangle. Those are arrays. This is not an array. It looks like a pizza slice. So when we do these, when we talk about arrays, it needs to have exactly two factors. Exactly two factors. No more, no less, exactly two factors. So let's take a look at some other numbers, and let's just try this. Let's put down a 2, 3, 4, 5, just for kicks. And let's throw a 6 in there. All right. 2 is an interesting number. It's actually the only even prime number. I've got, if I have 2 dots, I can make it a 1 by 2, or I can do a 2 by 1. But I've only got 2 composites, 2 factors. 2 is the only prime number, so it's kind of this weird thing. It's the only even prime number. Everything else that is even will always be a composite other than 2. When we talk about the number 3, I just did that one. There's only 2 ways to do it, and that is 1 and 3. There's no other way to do it. So let's take a look at 4. How can I make 4? Well, if I wanted to make an array again, what can I multiply together to get to 4? I could do it a couple different ways. I could always do 1 by 4. So 1 is always going to be a factor. Any number you multiply times 1 is going to give you, if you multiply 1 times itself, you always get that number. So whenever we're looking for factors, you can always do 1. And in this case, we've got 1 and 4. Those are factor pairs. There's actually another way to do this, though, which most of you probably know. But if I wanted to, I could also do a 2 by 2. And this actually creates something, another fancy term, that we refer to as a square number. We call it a square number because its array looks like a square. So our square numbers, or any numbers when you multiply themselves, both factors are the same. So if you go 2 times 2, you get 4. So 4 is a square number. 3 times 3, you get 9. 9 is a square number. 4 times 4, 16 is a square number. 5 times 5, 25 is a square number. And you can keep going, right? It'd be 36, 49, and you can go on and on and on, all the way up, and they go on infinitely. 5, so when we do 4, you can also have 2 in there. This makes this a composite number. This is a prime number, prime number. 5 is also going to be a prime number because there's only 2 factors, 1 and 5. 6 gets a little bit different because now I can do 1 and 6. These are factor pairs. But I can also do 2 and 3. That's my other factor pair. So if I wanted to make an array for 6, I could do it 2 different ways. I could do 1, 2, 3, 4, 5, 6. Or I could do it 1, 2, 3, 4, 5, 6. Either way, I've got a rectangular array. This is a rectangle, roughly. And that makes it so it is a composite. Prime, composite, prime, prime. There's 2 exceptions to all of this, and that's the weird. There's 2 weird numbers that don't really fit into this. So there's 2 numbers that are not prime or composite. You can think about this, rack your brain, maybe quiz your parents. But the 2 numbers that are not prime or composite, every number is prime or composite except for the numbers 1, because there's only one way to make an array of 1. It's just 1 by 1. So there's actually only 1 factor to it, which means it's not prime, it's not composite. There's just 1 factor to 1. There's only one to make 1. 1 times 1, so there's 1 factor. The other one is 0. Any number you multiply times 0 gives you 0. So it actually has like this weird infinite possibilities. It's kind of this weird number. So 1 and 0 really are not prime or composite, but every other number is going to either be prime or composite. As long as you think about it in arrays, can you multiply it and get there using more than one way? You can always use 1 times itself. Is there another way to get there? So think about that when you're doing prime and composites. Decimals up to, when we're dealing with decimals, this is a 100 square, which a lot of you guys are familiar with looking at. And if you look in this 100 square, there is exactly 100 little white squares in here. There's 100 of them. A lot of times we think about this as money. So that big green circle, if we think of that big green circle as $1, okay, there's 100 squares. So each one of these little squares, there's 100 of them. So this would be 1/100th. If we think about that as a penny, right? So you need 100 of these red squares to make up the green one. You need 100 of them to make that up. And if I just erase this $sign, you see exactly how we make these. So this would be 1.0, green square, 1.0. This little tiny one is 1/100th of that. And so here's our ones place, tens place, hundredths place. It is 1/100th. Now I left a gap in here, and that's because there's another one to think about. And that is if I were to, instead of thinking about it as a big long flat, if I think about it like a rod in our base 10 blocks, this blue rectangle, if I thought of just this blue rectangle, I could divide this whole box up. And if I just thought about each column like this as one whole thing, I would have 10 different columns. So I can think of this square, this whole green square, I could break it up into 10 different sections, and each one of those sections would be a tenth. And so that would be written as 0.1. Again, if I think about this as money, I would write this as, what do you need 10 of to make a dollar? It's a dime. So you would typically write this as this when you're dealing with money. And the value of one dime is the same as 10 pennies. So if I had 10 of these red squares, that would be the same as one dime, right? 10 pennies and one dime, it's the same value. And if I had 100 pennies or 10 dimes, my value would be $1. It'd be the same as just a dollar bill. So we can kind of use that idea as we're illustrating these concepts. So now I just erased these because I want to go over a few. So let's just shade some in. And if I start by just shading in, let's say this much. Well, how much did I just shade in? Okay, if I shaded in the entire square, I would have had a hole. I'd have one thing, right? If I shaded in that whole thing, it'd be 1. But I didn't. I didn't shade in one whole thing. I shaded in a part of it, so we're dealing with a fraction. So again, the whole thing, if I shaded in everything in here, it'd be 1. It'd be one whole thing, but I didn't. I shaded in this. So how much did I shade in? Well, there's more than one right answer. You could look at each one of these squares and say, all right, well, here's one square and here's another. And if I count up all of these squares, I shaded in 30 out of the 100 squares. And that is correct. That is not wrong. You could write this as a decimal. That says 30 hundredths. You would write that in as 30 hundredths. And that's right. That is not a wrong answer. It's just that there's another right one. I could also talk about this as just looking at these flats and how many of these blue sections, if I cut it like this, now I've got one here, another one here, and another one here. So I actually shaded in 3 out of the 10, right? So if you look at 3 out of the 10, if I shaded this in like this, and I had 10 different sections, following the lines, I shaded in 3 out of those 10. I can write this as 3/10. These are the same. Here's the fraction, here's the decimal. And just like if I had 30 pennies and 3 dimes, the value's the same. It's a different way to write it, but the value is the same. Whether you have 30 pennies or 3 dimes, it's the same amount of money. So now let's try another one. So let's shade in this time. I'm going to shade in this, this, and this much. So what did I just shade in? We could look at this a few different ways. I shaded in, if I think about it as those longs again, of those long blue sections, which I can, I shaded in 2 full sections, but not quite another. So I do have at least 2/10 there, but that's not a very good accurate description. So now I want to consider it of those smaller squares. Let's call them a red one. How many of these red squares would I have filled in with the green shading? Well, I can count by tens. 10, 20, 21, 22, 23, 24, 25. That'd be 25 out of the 100 squares are shaded in. And that would also be written as 0 and 25 hundredths. This is the ones place, tenths, hundredths place. So 25 hundredths were shaded in. So that's just another way to look at my values. Now let's flip it around. Let's say I wanted to shade in 73 hundredths, or 0 and 73 hundredths. It's the same thing, just written two different ways. When I want to do this, all I need to do is count by tens. Again, if I shaded in this little square right here, that's 1/100th. I need 73 of those. So here would be 10 of them, 20, 30, 40, 50, 60, 70, 71, 72, 73. There would be a representation of 73 hundredths shaded in. And let's try one more nice easy one. Let's say I wanted to shade in 4 tenths. Same thing as 0 and 4 tenths, written as a decimal. Now, again, if we're looking at tenths, we're looking at this whole thing, this rod, this one column, as being 1/10. So I need 4 of those. 1/10, 2/10, 3/10, 4/10. One common mistake students will make is they'll see 4/10 and they'll want to shade it in like this. But these are not equivalent. 4/10 is not equivalent to 4 hundredths, right? If somebody offered you 4 dimes or 4 pennies, would you say it doesn't matter because they're the same? No, 4 dimes is worth more. So make sure you're being careful with those and understanding that tenths and hundredths are very different. Here is 4 hundredths, 4 out of the 100 pieces. Here is 4 tenths, 4 out of the 10 pieces. So tenths are much bigger than hundredths. Making sure that you understand that component. So now let's talk about lines, line segments, and rays. These are ones that students sometimes get mixed up. I'll try to break them down. We've got lines, line segments, and rays. 3 different things. So when we talk about a line, a couple things to start with. Whenever we have a dot, we refer to this as a point. Just a little point. That's somewhere. We usually like to label these with a capital letter. It can be any letter you want. I tell people to stay away from things like O's or O's because they look like a 0. Sometimes can be tricky. Otherwise, you're usually fine. But we label it with a capital letter. I'll use the letter A. You name it. Points are like people. You try to give it a name. This one's A. So when we have a point, a line involves 2 points. All of these will involve 2 points. When we have a line, and I'll use a point and a point. A line goes through those 2 points and it extends infinitely in both directions. So this line does not stop here, right? It keeps going. It keeps going and going and going. In fact, if I were to put this green dot here on my line, and let's call my line AB, and let's call this green point C. C is actually on my line because this line continues on and on in this direction. It goes on and on forever. It goes on until it hits something. It just keeps going, right? That's what a line does. It continues on and on forever until it hits something. So even point C here is actually on this line because it would go through here. So we name this, if we had to write it, we can call this line AB, and it's actually the same thing as line BA. We can call it either way, whether we're looking at it upside down or not. It doesn't actually change what it is. So this is a line. It goes on and on forever in both directions until it hits something. Guys, these points, everything on here, if I were to put a point, another point here, here, that's on there. This point is on there. This point is on there. This point is on there. All of those are on there on line AB. Let's take a look at another one. I'll use blue for line segments. So when we talk about line segments, similar to a line, we're going to have 2 points. They can go in any direction. And connecting those points, we've got a line segment. Let's call this one D and E. The difference is they don't go on and on forever. And so if I added another point here, point C, C isn't on there because these end at the points. In fact, these really are a special kind of points. We call these end points because the line ends there. So that is an end point. C is not on this. We label this either line segment DE, or you could call it line segment ED. Either way, it's the same thing, but again, it stops. It does not go any further than this point. The line does not continue. So if I were to put a green dot here, it is on the line segment. If I put it here, it is on the line segment. If I put it here, it is no longer on the line segment. Which brings us to our last one, rays. And I like to think about the sun, big ball of burning gas. That's why I use this one in yellow. And light comes off of that one point and goes on and on forever in one direction. And that's what a ray is. So here we've got endpoints on a line segment. We've got just points on a line, and we kind of combine those two. And so when we do a ray, we have an endpoint. Let's call this F. And we've got another point, let's call it G. And our ray goes through it. So now I've got an endpoint and a point. So it goes on and on forever, infinitely in one direction. Just like the sun has rays of light that go on and on until they hit something, which is maybe the earth. So it just goes on and on forever and ever and ever. If I look at my green dots, this point is on the ray. This point is on the ray. This point is still on the ray, remember? This goes on and on forever. This little arrow tells me it goes on and on forever until it hits something. However, this point is not because it is an endpoint. So here's the endpoint. We can call this ray, there's only one name now. It's called FG. We cannot call it GF because it doesn't start with G. We always have to start with the endpoint. So we cannot call this ray GF, it's only FG. That is the one name for it. So when we come to rays, there's only one name. If it's a line segment or a line, it's got two names. It can be called either one. But if it's a ray, there's only one correct name. And those are the differences between lines, line segments, and rays. When we look at compasses, we're going to talk about angles of 90, 180, 270, 360. Whenever you look at a compass, I could put up like 3 or so different ones. They always have usually north is 0. That's at the top. And as you go around, it's broken up into 360 different little lines. So 90, it would make a right angle. If I drew on this and I connected 0 to 90, you'll see this is a 90-degree angle. We call that a right angle. Okay, and it's the same on any compass. It's a 90-degree angle. If I go 90 plus 90, I would get 180. And so now, if you look at this one, here's a 90-degree angle, here's a 90-degree angle. 90 plus 90 is 180. If I go a little bit further and go 180 plus 90, I would get 270. And that's what this one is. Right, here's 90 plus 90 more plus 90 more. I have 270. And finally, if I go 270 plus 90, I would get 360. That's this last turn, 360. So let's use an arrow here. This arrow is facing north. If I were to turn 90 degrees, it would be facing east. If I turn 90 degrees more, there'd be a total of 180 degrees, and I'd be facing south. And if I did that one more time, 90 degrees, I'd be facing 270 degrees, because 90 plus 90 plus 90 is 270. And the last one would be 360. I made a full turn, came right back to where I started. Where it gets a little bit tricky when we talk about angles and degrees is we still talk about this being a 90-degree turn, right? Whenever you do a quarter turn, 1/4 of a turn, this is still a 90-degree turn. Okay, it's still making a right angle. So let's take a look at what that means. So whenever we are talking about turns, whatever we start with, if I have a picture of myself fighting Darth Vader, I can take this picture and rotate it 90 degrees. That was 1/4 turn, right? So this would be a 90-degree turn. It moved from starting here to now here, and that is 90 degrees. Okay? It's a 90-degree turn. This is now the upper direction. It's a 90-degree turn. I could turn it 90 more degrees, like this. And now I've actually turned it a total of 180 degrees. Okay? It's upside down. It is totally opposite of what it was before. It's 180 degrees. It's opposite of what it started with. Okay? So now we're at 180 degrees. I could turn this one more time. 270 degrees. 360 degrees, and now it's back to where it started. So we have to just kind of keep those main numbers in line, just like a compass. The main thing is understanding those key ones. There's 360 degrees in a circle. Okay, you can move it just a few, and we can talk about those measurements as well. This would be like a 45-degree turn. You don't have to worry about that for this one. Here's a 0-degree turn or a 360-degree turn. It's the same thing. They're facing up. As we turn it 90 degrees, it would look like that. If I start here at 0 degrees, I could turn it a quarter turn this one. I did turn it 90 degrees. This would be 90 degrees counterclockwise. I turned it the opposite of a clock. It was still 90 degrees counter turn. If I start here and turn it all the way so it's upside down, that's a 180-degree turn. So starting at the top, turning it here, 180 degrees counterclockwise. So keeping those main numbers in line, hopefully those are numbers that are fairly straightforward. I hope those that helped you out and you understand what's going on for the IXL. If you do have any questions, please let me know. I'd be happy to help you. There are also links in the dojo post that do direct you to other people explaining the same things that I just did. Maybe in a different way it could help you as well. If you're still struggling, please let me know. I want to be there to help you. Teachers are here to help you guys out. We know it's difficult and you guys are doing the best you can. So keep up the good work. We know that you're trying And so if you do have questions, please let us know. I hope you guys have a great week, and I'll talk to you later.